Rutherford based on his famous gold foil experiment. I would like you to remember some of the details of these experiments. So, what is the Rutherford's model of the atom? He published his atomic theory describing the atom as having a central positive nucleus, and then he said the electrons are actually surrounding the nucleus in what are called orbits. Now, this is the model of Rutherford. He said the nucleus is concentrated at the center, and the nucleus carries a positive electric charge. So, the positive charge of the atom is concentrated at the center. It is called the nucleus. And most of the mass of the atom is actually concentrated at the nucleus. The negatively charged electrons move around that nucleus in orbits. And that is the picture of the atom Rutherford. Now this is what Rutherford said. The positive nucleus and the electrons, the negatively charged electrons, are moving around it in orbits. The amount of positive charge in the nucleus equal to the amount of negative charge carried by the electrons. So that looks pretty good, is that right? Okay. Now later, when Rutherford bombarded nitrogen with alpha particles. Now remember I told you the best way to study an atom is to try and break it open. In other words, fire a bullet into the atom. Rutherford did not stop with his gold foil experiment. He continued with many more of his novel way to probe into the atom. Now, he bombarded atoms with nitrogen atoms. He bombarded nitrogen atoms with alpha particles, and he observed that the positively charged nucleus is actually made up of particles. A nucleus is not a single body. He observed that you can break the nucleus into pieces, and he said the nucleus is actually made up of protons, which are positively charged particles. Now, here you have protons. I have showed them using red color. They are protons. So, according to Rutherford's model, the nucleus of the atom is made up of protons. Now, later on, actually Rutherford did not discover this. He suggested to one of his assistants who was working in the lab, that he said, now I have a hunch that the nucleus also contains some other particles, because the mass of the nucleus suggests that it is not just made of protons alone. It must contain some other particles. Now Chadwick, that was his assistant's name, took up this challenge and he started working on it. And ultimately, in 1935, Chadwick discovered that the nucleus also contains another type of particles which are not electrically charged. They are neutral particles. And he called them neutrons. So look at the way the picture of the atom now emerges. The nucleus of the atom is now understood to be made up of positively charged protons and electrically neutral neutrons. So you got protons and neutrons. So the mass of the nucleus is made up of the mass of protons and neutrons. The electric charge of the nucleus is made up of the charge carried by protons, which are positive. Alright. Now protons have a mass of 1.673 times 10 to the negative 27 kilogram. In fact, protons are almost 2,000 times more massive than electrons. So compared with protons, electrons are very light. However, protons could not be the only particles in the nucleus, because the number of protons in any given element has a mass less than the weight of the nucleus. Well, that's what I was telling you. The mass of the nucleus suggests that protons are not the only particles in the nucleus. So he argued that a third neutrally charged particle must exist. Rutherford made that argument, but he did not discover that particle. The credit for discovering that particle went to his assistant Chadwick, who was given a Nobel Prize for it in 1935. So it was James Chadwick, a British physicist and a co-worker of Rutherford. In fact, it's not good to say a co-worker. He was an assistant working in the lab who discovered the third subatomic particle, which is the neutron. So what are the type of subatomic particles we know so far? An atom has now a nucleus. The nucleus contains protons that are positively charged, neutrons that are electrically neutral, and of course outside you have electrons that are negatively charged. And neutrons have a mass of 1.675 times 10 to the negative 27 kilogram. So if you notice, the mass of a neutron is almost the same as the mass of a proton. You can see a neutron is slightly more heavier. In fact, later on we will talk about this. A neutron actually can be, don't tell this to anybody, a neutron can be broken down into a proton and an electron. Alright, keep this with you. We will talk about this in the next lesson. A neutron can be broken down into a proton and an electron. How amazing these particles are. Now, the nuclear model of the atom developed by Rutherford suggests that most of the atom consists of empty space. The nucleus is concentrated at the center, the core, and the electrons are so tiny they just go around the nucleus, and much of the atom is actually empty space. And that's the reason why many of the alpha particles that Rutherford used as bullets went through the gold foil without even knowing that they were going through a material. Most of the atom is actually empty space. Now, if the nucleus of an atom, now this is the nucleus of, say, gold. If the nucleus of the atom and the sun are represented by the radius of 30 centimeter. In fact, if you increase the size of a gold nucleus so that it is now 30 centimeters in diameter, and you decrease the diameter of the sun and bring it down to 30 centimeter, here is the sun, and here is the gold nucleus. If both are made of the same size, you know, looking at the solar system, where will our Earth be? How far will our Earth be? You see, this is 30 centimeter. Our Earth will simply be 100 meters from the sun in that scale. And in the same scale, when this is the nucleus, the first electron will be 5 kilometers away. You see that? If you bring down the solar system and a gold atom to the same scale, when the Earth is 100 meters from the sun, the first electron will be 5 kilometers from the nucleus. You can imagine the enormity of the empty space that an atom is.